Hello and welcome back to another stream. Today I'm just going to be showing you what I've built recently, or not recently but ever. Yeah, just give me a second to make sure everything is working. Hopefully it is. Yeah, everything seems to be working. Okay, so let's start on this world. These are just showing what the things do. Those are self-explanatory. So, okay. I haven't seen this stuff in a while, so I don't actually know what this is. Okay, well, that's cool, I guess. Alright, okay. Sure. I'm not gonna try that because it's broken. Combination lock. I believe I set it to... Okay, it wasn't that. It was... that, yeah, okay. There's some other stuff. Okay. Traffic light. Okay. Alright. What is this? Okay. Is it? I think it's getting... Oh yeah, it's changing colours, look at that. Alright. Just I have no clue what this is. Alright. Okay. So this is a... Okay, sure. Alright. This is a 4-bit adder. Alright, so what... 3 add 1 is 4. Sure, that makes sense. Okay. What's this? What is this? Luckily I labelled everything, so I know what things are. Alright. Oh yeah, here's the other ones. They change colours. Yep, alright. Oh yeah, I can set the colour on this one. You know, this isn't actually as interesting as I thought. I'd made this to see if it would get all the way to the end, but now that I'm looking at it, each one's a 50-50, apparently. So it would be a 50% chance for this one to turn on, 25% chance for this one to turn on, and 12.5, and it... So it'd be very tiny possibility that this would turn on. Yeah. I don't know what this is. Like, alright. I didn't label... Why did I not label these? That doesn't... It's not even connected to anything. Okay. This should... I should be able to write to this and then read from it. Yeah. Alright. I'm just gonna... Sure. I will show you that in a minute. Most of these don't work, so and I don't really know what some of this stuff is. Alright, well that was kind of boring. Let's go to here. So, I built this. Yeah. Anyway, this sends a signal from each. Well, I'll just show you. So, sections, info, input, this station info, station. What? Because I don't remember how this works. Input, info input. Well, I'm not going to be able to get any information from that. So, let's do that. Sections? I don't know what it means by section. I mean, I made this, but I don't know what... This station info. Oh, okay, so I can read from the different... Oh. Oh, so it can save it. Oh, right, yeah. Okay. So if I send that to that, and then I read from that. Okay, alright. Okay. And then I wanted to send it to, let's say the same station I'm at. Alright, then it should not... What? Oh. There we go. Okay. So say I wanted to send this to station 4 and 5. Okay. Then I come over to station 7. Station 4. Okay. So up here, sent from number 1, and then there you go. And then over here, station 5. Yeah, alright. So I can see that that still works. Alright. And it's all done with this extremely complicated system, which probably could have been done 1,000 times easier, because I remember this taking me so long to wire up everything. Because there's, I want to say thousands of wires here. Luckily you don't have to wire everything up individually, because you can multi-select them. So if I wanted to... If I want... just give me a second. If I wanted to take all of these and then just send it to one, or that one and then there, I can do that. And it's the same thing I used to do all of that, so... yeah. Alright, so there's that. Let's see, let's try this one. Okay, so this is gonna, so you see the signal down here? I can make it travel in a line that I want it to travel in, but if there's like a break there, like that, I'm doing a really bad job at explaining things, but it takes the path I want it to take. Pretty much. Kind of. Yeah. And I'm not sure what that is. Let's try. Alright. Oh yeah, I built this recently. It's a counter, but I think it's 19 long. Let me count. $23 long. Okay. And it just adds 1 to the same number, and it counts up. So it just keeps going. What I can do is set the speed up to, like, whatever number this is. 100,000, yeah, okay. And it still takes a while for it to build up. You can see it counting up here. In binary. Okay. So yeah, there's that. I mean, I built this on stream, so people who are watching that should know what this is. It can save numbers in I can't remember how many. I think it was 8 kilobytes of information it can save. So if I wanted to save that in 5, then I should be able to flip that. Okay, and then unflip. Okay, and then if I set it to read instead, and I should be able to read it from 5. Yeah, there we go. Okay, and then I can clear it. Yeah, so that can save information in this amount, which is 8 kilobytes or 6 kilobytes, I think. There's some other circuits over here, but they were trying to help me figure out that. Something else I built, I actually managed to get this working yesterday, so it's a really recent thing. It's an encoder, so it can take an 8-bit number and then use a 40-bit key to encode it, and then I built a machine to decode it as well. So say I have the number 7, and then this selects which type of encoding I want to use, and then this is the key for that type. And I can do that 4 times in a row. It's a very complicated machine. Well, it's not that complicated, but it is quite complicated. So 0, 0 is the inverter. Yeah, and I can just put in a key like that, and then I think this one's XOR, yeah, so let's just do that. Shifting, I believe, and then substituting. Yeah, so I've managed to turn 7 into whatever that number is, and then this just stores the data. So I can now take this, put it over here, then take this number. Let me just see if I can remember it. And then it takes the same key and gives me the original number back. So it's decoded the number. I could do this manually and put the key in, but it is just quicker to copy it over. So, yeah. Let me put this back. Let me unflip these quickly. Alright, so over here I have all of the individual methods to encode and decode. So, this one turns an 8-bit number, this top section takes an 8-bit number and turns it into a 3-bit number, and then uses that 3-bit number to shift the data along. So if I have a 1 and I wanted to shift it along by 1, it turns into 2, and then I can do more, and yeah. It's really difficult to explain well, but yeah. This is the inverter, so you put in a number and it inverts it. This is the substitution one, so if I just do that, then if there's a 0 0 like that, it will change it to this. If there's a 1 1 like this, it will change it to, I don't know, that. If there's a 0 1, it will change it to that, and then 1 0 will change to that. And then it should, yeah, it gave me that out. And then I just take that with the same key, put it into here, and it should give me that back. But I'm not going to do that because it will take a while. All of this stuff did take me a long time to make. I think all of these individual things took me, I don't know, a month, maybe 2 weeks to make all of it. And a lot of help from ChatGPT. This is the XORing one, so I do that and it gives me that, and then I take this with the same key and it gives me the original data back. Yeah, that's quite easy. This was an attempt to make a random key for the substitution one, and this turns the 8-bit number into a 3-bit number by doing a series of adding bits, and then this generates a random 8-bit number. Well, it's kind of random. It's not really actually random, but it's kind of random. And you can see all of those machines lined up. Yeah, I don't know if there's actually anything else. Okay, let's try this one. I can't actually remember what's in. Oh, that's an annoying ground colour. Why did I choose that? Oh, right, yeah, it's that. Oh, I remember this. Okay, so I made a car, kind of, a car engine. So this isn't exactly how a car works, but it half works like how a car would work. This is the starting motor. So it cycles round, and then the engine starts up in the right pattern of the V8. Then you have the different gear shifters here. I think this is 1. No, that's 8. Alright, this should be 1. Yeah, it speeds up slightly. This is number 2, speeds up again. Number 3 speeds up again. And then number 4 speeds it up faster. And then, oh, yeah, sometimes it has a slight problem. But then this one turns on all of the gears at the same time, so it looks like that. Yeah. And then I can just turn the engine off. So this is the simple version, and then okay, this one I just made it look nicer. Then this one has 2, or I think it's 2 other things. It's got a fuel system and a battery. So, to charge the battery, the engine needs to be on. I think that's called an alternator in a car. This is the battery, and then this is the fuel system, which took me a while to figure out. So when the car's on, the fuel goes down, but the engine charges, and the car won't start without fuel or power. I have a quick button up here to charge the engine, the battery slightly. So then I can flip the switch, and then it starts, which then charges the battery. But now you can see the fuel going down because the engine's on. So when it runs out of fuel, it should stop. Yeah, there we go. Okay, and then to refuel the car, you have to obviously take it to like a petrol station and then refill it. And you can see it refilling. Yeah. So there's my car engine, kind of. Yep. Okay. And seeing as the engine's not on, the fuel won't go down. So I just thought that was kind of cool. What else is there? Satisfying. Oh, right, yeah. it's just a circle that I can input stuff in it, and then I can turn it off like that. Yeah. I mean, it's quite satisfying. It's not the most satisfying, but it's kind of cool. Yeah. So there's that, the only thing in that world. The things add, sub, divide, multiply, maybe? Let's try this one. I was trying to make a maze generation thing, but it just didn't work. Like, at all. For some reason, so I kind of gave up on that. Yeah. What else is there? Random specific logic system, I don't know. Oh, that's a disturbing flaw. I don't know. Oh, right, I was trying to make... Yeah, this never worked for some reason, and I couldn't figure out why it just decided not to work. I don't even, yeah. For some reason, I just have a couple random worlds that just don't have anything interesting in them, and like half-built machines. Oh, I know what this is. It's a wire tester. So, this is the wire, and you can just take it in and out like that. This tests the wire, and if it doesn't turn green, then it just doesn't work. And then you can also see that, I guess, and then you just press that and it resets. So if I break the wire in like 2 places, you can see if I flip the switch and then unflip it, you can see where the problems are. So it's in wire 6 and wire 11, which is that one and that one. And then you can see it all lit up. Yeah, so, yeah. I think that's literally everything I've built. Is that? I'm not sure. Yeah. Yeah, I think that's everything I've built. And actually, I don't have any ideas for what else to build. I'm just gonna... there we go. Okay, I'm just gonna, like, think for a second to see what I should build while you just look at this nice rainbow screen. You know, I had some ideas on ChatGPT, so let me have a look there. What do I ask ChatGPT? Alright, why is my computer making a really weird noise right now? Okay. I'm just gonna have to ignore it. Okay, so I have some suggestions from ChatGPT. Basic circuits. I've made all of those already. Combinational logic circuits. Half adder, full adder, multiplexers, and demultiplexers. Create a circuit that can route one of these several input signals to a single output, or a single input to several outputs. No, I can't do that. Sequential logic circuits. Flip-flops, alright, okay. Counters, I built that already. Shift register. Shift register. Okay. I think I've done that already, yeah. Complex systems. Algorithmic and logic unit. I've built that already. Simple CPU. I guess I could build a simple CPU, but I don't think I can. Games and puzzles. Binary calculator. Build a calculator that can perform basic binary operations. Okay. Logic-based puzzles. Create a puzzle where the player must design a circuit to achieve a specific output. Similar to how logic games typically... that's interesting. Possibly. Interactive systems. Digital lock. I built that already. Traffic light controller. Build a circuit that simulates the controller of a traffic light system cycling through the states based on a clock or input signals. I mean, I've kind of already built everything. I guess the logic-based puzzles would be cool. But I'd be testing myself, so that wouldn't be very good. Let me ask it for anything else. Alright. Signal processing. Pulse width modulation generator. Create a circuit that generates pulse width modulation signals by varying the duty cycle based on the input useful. Okay, I don't really know what that is, to be honest. Alright, I built that already. Memory and storage. Finite state machines. Simple game AI. Implement a finite state machine that acts as a basic AI for the simple games such as tic-tac-toe, or where the AI makes decisions based on predefined states. Alright, that could be interesting. Traffic insertion controller. Create a more complex traffic light controller that manages multiple intersections with different timing based on traffic conditions. Error detection and correction. Actually, there was something I wanted to build, so I might try and give that a go. Okay, I think I know what I want to build. Okay. Where is it? It's this one. Alright. Okay, so I wanted to make a circuit that repairs or bypasses a broken piece of thing by itself. So like a system of wires that if one is broken, then it bypasses it and goes to the next one across. Which is kind of what I tried to do with this one, but it can't repair itself. I have to repair it. So I'm not sure. Oh, and a couple streams ago, I got stuck under the floor. And I found another fix for it if that happens. So instead of finding your coordinates and stuff, if you just do a no clip. Alright, and then while you're flying, let me try that again. While you're flying, you can pass through things, including the floor. So, there's another solution for that if any of you are having that problem. So, how am I gonna do? How am I gonna build this? So I need a wire that. Okay, let me build something quickly. So I'm gonna need like a long wire with multiple bits like this, where a signal will travel down the wire and end up at the other side unless there's a break in the wire, in which case like it will divert the signal, kind of. Alright, let me connect all these. Okay, so at the moment the signal travels down the wire perfectly fine. But I need to build a system that checks if there's a break in the wire, finds where the break is, and then sends the signal on a different path. Like that. Yeah. Alright, so this is going to be the starting wire. And then I'm going to have another wire next to it. No, I can't have that actually. So I'm gonna need to build a system that knows what should be happening and checks it against what's actually happening. Which is going to be difficult to do, because I have no clue how to do that. Which is extremely helpful right now. Yeah. This is a challenge. Let me do that then, so I can control it like this. Alright, so I'm gonna need a lot of AND gates and to know what the wire should be doing. Okay, so if I move that over actually. No. Okay, let's start with the lot of AND gates part and get this, which alright, let's copy that, move it to there, and then I can just fill in the rest. Alright, so there we go. Okay, but that checks this wire, and then I need to know what it needs to be as well. Okay. So if I have another one of these, and I have why did I do that? I just crouched to hop up something, and I could have just done. I'm so. So I can place all of those, but if I select these, copy them, and then place them there. Alright, and assuming there isn't a break in those, it needs to check these as well. Okay, so it checks the wire against what it should be. So if I flip that, all of the AND gates are on, yeah. But if I break that, all of the AND gates past that turn off. I felt like I didn't actually need to do that. Because I could just tell that from the wire anyway. I didn't need to AND gate at all. Alright, yeah, that was pointless. So, if I get a relay and place a relay next to all of these, okay. Wait, no. No. I need something that checks where the break is. So, if I have an AND gate which checks both of those, and then an AND gate that checks that and that, an AND gate which checks that and that, okay, up until here, which checks that and that. No. No, I need something that will. I need something that. Oh, I need XOR gates. Yeah. Maybe? I think so. Yeah. If I get some XOR gates, but I need to stack them somehow, so let me get this. This is probably the worst way to be doing this, but what? Sure. I don't know why, but the offset thing doesn't work. Alright, well, I guess if I just do that then. Okay, all of those, and then let's place all of these, and then I think one also needs to be there possibly. Oh, okay. So this one checks that against that, and if both of them are on, then the output is off. So if that one and that one are on, then the output is off. That one and that one, that one and that one, that one and okay, so that needs to check that and that. Then that needs to check that and that. That needs to check that and that. That is alright. So that and that, that, that and that, that and that. Alright, so all of these just need to go into all of these. Okay. And then these also all need to go up into these. Alright, yeah, since that's the end one, I don't need that. Alright, so this should now detect where the break is. Okay. Okay, I'm already seeing a problem with this, because then if this remakes a connection there, it'll turn off and then break the connection again. Okay, well, I'll keep going and see how I'm gonna do this. Okay, so I now know where the break is compared to everything else. And so the signal will be routed through this and then go through a relay no, it needs to what it needs to do is it needs to save it. So yeah. Okay. this need to go into these, but only half of them, like that, okay. Then they also need to go into the same ones, but the up position, like that, okay. So it will save it, and even if the thing is rejoined, then it still outputs. Okay. And then all of these need to do the same but different. If that makes any sense. Alright, it only needs to go to... so I don't need that. Okay. So this should now say where the break is, and then save that. So when it's repaired, it will turn off, but this will stay on. Okay. Now I need some way of taking this and then changing it to this somehow. Alright, so these need to turn on the relays if they're on. That doesn't make any sense. These need to check. No, they need to let a signal through the relay. So it needs to take this signal. No, it doesn't. What I need to do is put that there and extend it out like that, and I need a bunch of through pegs, and I need to just place them all down, but not do a really bad job. Alright. Okay. Are there any connections? I don't think there are, no. So, this needs to take all of these, like that. And then okay. So another slight problem is I'm gonna need to use buffers. Actually, yeah. Okay, I don't need that many, I can just fill that in. Like that. Okay, and then all of those do that. So it does that. Okay. So it's fixed it. Okay. And then what would happen is a repair person would come along, fix that, and then manually send a signal to that. How would they do that? I would need, like, no, I don't want to do that. I'm do them. Alright. If I get a switch, and then I can do that, yeah. Yep, so I just get a bunch of these and connect them to there. Alright, so this should be a self-repairing wire now. So what happens if I break a peg? I'll test that in a second. Oh, yeah, alright, there we go. So, if I turn the wire on, then I purposefully destroy one, it will send the signal back through and repair itself. Okay. Alright, what happens if I destroy another one? And another one? It keeps repairing itself. That is really cool, actually. Okay. And then once they have been repaired, you just flip one of those, and the wire's perfectly functioning again. Well, isn't that great? I'm actually surprised that worked. Alright, I just want to test what happens if I break a peg. How are the pegs connected? They just go to there and there. Alright, ready? Alright, so it doesn't work if a peg is destroyed, but it still works if a wire is destroyed. That goes to there, goes to there, and goes to, well, goes from, yeah, like that. Okay, there we go. Alright, I'm gonna have to go then, because it's getting quite late and I need to go to bed. So, I will say goodbye then. I hope everyone has enjoyed the stream. Thank you for watching, because we got 6 people watching at one time earlier, which was nice. So, have a good rest of your day or night, whatever time it is where you are. Goodbye.